Hello viewers, welcome back to my Speed Max and Math Electrical for you. As in the previous video, we already discussed out how to find out the voltage regulation for a given alternator and what are the methods are available to determine the voltage regulation of an alternator. In this video, we are going to see the voltage regulation calculation in which the open circuit data and short circuit data for a three-phase star connected 866 volt with the power rating of 100 kVA alternator is given. The OC test data and the corresponding line voltages are given. Students are requested to convert all your line voltages to phase voltages. To divide it by root 3, we'll get 98.88. For every field current, whatever it is given, the corresponding open circuit voltages will be given. To that corresponding input voltage, convert the VOC line voltage to the phase voltage for 173, for 310, 485, 605, 728 and for 790. So the important to convert for this is because in the plotting the graph, all the data we have to express in per phase. Now the corresponding of the field current of 1 ampere which produces a short circuit current of 25 ampere is given, and the armature resistance RA value per phase is given as 0.15 and at the power factor of 0.8 lagging condition is also given. This method is called as the pessimistic method. As the previous slide, we have seen how to convert all the values of your field current, line voltages and the corresponding of your phase voltage. Before plotting the graph, there are some basic details which has to be calculated. We'll see the formulas one by one. How to calculate the synchronous impedances, VOC and IAC, all the data it has to be expressed in per phase, and synchronous reactance is given as Z is the whole square minus RA the whole square, and E phase the whole square is given by V phase into cos phi plus IA into RA, V phase into sin phi, IA into synchronous reactance the whole square. As already discussed out, how to calculate the percentage regulation E phase minus V phase divided by V phase. The preliminary data which you first required is your IL value. Using the power formula, P is equal to root 3 times of VL into IL into 10 power minus 3. From this, IL can be calculated as P by root 3 into VL into 10 power minus 3. On substituting the value of your alternator rating and the star connected alternator input voltage, we can able to find out the IL value as IL is equal to IA phase. Since it is in star connected, your IL value will be equal to your I phase value. Now we can able to plot the graph. First detail, we'll try to plot your open circuit characteristics. Second, we'll try to plot your short circuit characteristics. With knowing the value of IASC, we can able to calculate what is the open circuit voltage. So first step, with the data from the previous table, we can plot your open circuit characteristics. All the data are marked and then we can plot the graph. For the field current of 1 ampere, the short circuit current is given as 25 ampere, which is given as IAC as 25. With this data, we can plot your short circuit characteristics. Now with knowing the power calculation, we can able to find out what is IL value and that is IA phase value since it is star connected. With knowing this IL is equal to IA phase, project from 66.67 to meet your short circuit characteristics and project vertically to meet the IF value horizontally. From that same value of your 2.4 ampere, project the same to the open circuit characteristics and project horizontally to meet the VOC value, and that VOC value from the graph we got it as 240 volt. Now with knowing all these values, we can able to calculate the synchronous impedance value VOC divided by IASC. So VOC already we got it as 240 volt and IASC we got it as 66.7 with that 3.6 ohm per phase, and RA value is given as 0.15. With knowing the formula of the synchronous impedance, we substitute all the values 3.6 the whole square minus 0.15 the whole square. After value, take the square root, we'll get 3.597 ohm per phase. With knowing the values from the data, phase voltage is given as 500 volt and power factor is given as 0.8. On substituting 0.8, we can take the sine value, sine phi as 0.6, with synchronous impedance is given as 3.6 and synchronous reactance we got it as 3.957 and RA value is given as 0.15 ohm. For 0.8 power factor lagging condition, we are going to find out the voltage regulation by using the E phase formula. Thanks for. With knowing the formula of E phase value, substituting all the values, 500 into 0.8, 66.67 into 0.15, 500 into 0.6, 66.7 into 3.57, the whole square. With that, we can able to calculate the E phase value as 677.86 volt. Then we can find out the percentage regulation by substituting all the values. Ensure that always the phase voltage value what you are going to obtain will be less than your E phase value. With that, you are going to obtain the percentage regulation as plus 35.57. Like, share and subscribe to my channel. Overall, we'll just summarize the problem. Plotting the graph, we have written what is IL value, what is the phase voltage, what is E phase value, what is synchronous impedance value, synchronous reactance value, and RA value and percentage regulation. Thanks for watching and subscribe to my channel.